This is the demo for Lab 4. The first thing we'll need to do is open up the binomial calculator in StatCrunch. And today we'll be using the binomial calculator as well as the normal distribution calculator. In StatCrunch, if you click Stat, then Calculators, then select Binomial, we get the binomial calculator. So let's look at this problem in the textbook. I'm going to look at number 39. Your lab will have you doing number 37. But let's look at this lab and find the parameters n and p that we need to plug in order to use the calculator. Now as we read this, we see the probability a randomly selected individual will not cover his or her mouth when sneezing is 0.267. That would be the p-value. Now later on here it says, suppose you sit on a bench in a mall and observe people's habits as they sneeze. What is the probability that among 10 randomly observed individuals, exactly 4 do not cover their mouth when sneezing? 10 is the number of trials, the number of observations. So what we have for parameters would be n, the number of observations, is 10, and p, the probability of success, is 0.267. And then we can calculate things like the probability that exactly 4 people did not cover their mouth. We can calculate the probability that less than 3 people did not cover their mouth. We can calculate the probability that at least 6 people did not cover their mouth. So pay attention to the language. Make sure that you are careful about strict inequality here versus inclusive inequality here. Phrases like at most, at least would indicate inclusive inequality. Things like less than, more than would indicate exclusive or strict inequality. So be careful about which you choose. The next thing we'll do is use the normal distribution calculator. If we go to Stat, Calculators, Normal, we open the normal distribution calculator. The first thing we need to do when we're using this is type in the appropriate mean and standard deviation. Let's type in a mean of 50 and a standard deviation of 2.4. Now we're able to compute the probability for a given boundary value. Let's calculate the probability that our variable is less than or equal to 48. And what we see here is we have a shaded region. We're calculating the probability that x is less than or equal to 48, which is equivalent to the area that's shaded here. We can also switch that to calculate the probability that x is greater than or equal to 48, and that would be the complement, or 1 minus the previous value. We can also calculate the probability that x is between, for example, 44 and 51. Oops, excuse me, 51, wrong value. So between 44 and 51, and compute. And so we see that the probability that x is between 44 and 51 is given here. It's also equivalent to the shaded region here. When working with percentiles, for example the 35th percentile, what we want to do is type in our percentile value, 0.35, in the probability output area here. Make sure that your inequality is set to less than or equal to, and click Compute. And this shows you that 49, approximately 49, is the x value that cuts off the lower 35%. That x value is the 35th percentile. When we're working with z alpha, first of all, z indicates we need to be in the standard normal distribution with a mean of 0 and a standard deviation of 1. When looking for z alpha, we're talking about a right tail area. Z 0.05, for example, what we're looking for is 0.05 being the area in the right tail. So we're looking for the x value, or the z-score, that puts 0.05 is the area in the right tail. So we need to make sure that this is set to greater than or equal to, and put the 0.05 there in the probability, and what we see is that z.05 is 1.6448, etc. So we have our z alpha, and z alpha typically refers to a right tail area. Z.025, just type in 0.025 here in the probability box and compute, and we get about 1.96. So that should wrap it up for the Lab 4 demo. Please ask if you have any additional questions.